Hello interwebs, welcome to Let's Fix Computers. I've got a minis forum here, which has been sent in with some kind of power fault, so it doesn't turn on. My understanding from the customer's description is they took it apart and they identified some power fault on the motherboard, but didn't know enough to be able to resolve it themselves. They saw there was something wrong but couldn't get to the bottom of it. So they sent it in hoping that I could instead. So let's take this thing apart and see what we can find. So these little mini PCs, they are basically headless laptops, so you know, they're pretty easy to approach if you've done any kind of laptop work before. We've seen these in on the channel a couple of times as well, so it's the usual thing where we're kind of expecting like dead capacitors, things like that, the usual story. Customer reckons that there's something up with the input MOSFETs, so I'm going to pay particular attention to that, but I think there might be a little bit more to it than that. And I'll explain why when we get in. So let me just zap the rest of these screws out and take some assessment measurements and just check if we've got something that looks vaguely viable, and we'll go from there. These minis forum chassis are kind of a ball ache to disassemble. It's really hard work to get the motherboard out. You've got to do some pretty ugly prying. Okay, there we go. I think we're going. Ugh. Oh, the whole thing is coming out. Oh, I've got to get the Wi-Fi antenna. Oh, it's awful. Alright, I can see we've got problems here already. If I hold this up to the camera here, there you go. See that little dot on that input MOSFET there? Yeah, there's your problem. So I'm just going to go ahead and roll the intro right away. I'll see you in a moment, folks. This video is sponsored by FlexiSpot and the E7 series of 4-leg standing desks. I've been using FlexiSpot desks for years now, and their versatility as workbenches is unmatched. Sometimes I want to sit down with my work, sometimes it's easier to stand, and the E7 adjusts to any height I need it to be at. The 4-leg design makes it drastically more stable than 2-leg desks, as well as giving a huge load capacity for multi-screen setups, lab equipment, or a heavy PC. The memory preset buttons allow me to dial in my favourite positions, so I can switch from sitting to standing in a single button press and get the same result every time. The E7 Plus comes with a 10-year warranty, while the Pro and Plus Max models get a colossal 15-year warranty to ensure peace of mind. If you're looking to upgrade your workspace, FlexiSpot offers a wide range of standing desks, ergonomic chairs, sofas, and other ergonomic furniture to suit different needs. Right now, FlexiSpot is celebrating its 10th year anniversary this August with some amazing offers. On the 31st of August, don't miss the flash sale from 10 AM to 11:59 AM. Use code ANUK12 to enjoy 12% off site-wide. Check out all the anniversary deals through my link in the description below. So here's that DC-in MOSFET I just pointed out, and straight down from the top it's hard to see the damage. But there's two things that we can look out for is, number one, you can see we've actually got some solder balls sticking out the side there. So there's actually been a major heat surge that has melted solder and pushed it out the side. So that's a problem. And then if I just turn it sideways slightly, then that bump in it becomes a lot more obvious and easy to see. So this guy's clearly failed. Let's follow the power input and see what this thing is actually doing. So if we move backwards a little bit, here's the back of the DC-in jack. So that will be the positive pin coming in there. And if we come in, you can see that's going onto this trace here. Then there's a TVS diode there that looks extremely undersized, but whatever, that provides some static protection and stuff like that. And then that's coming back through here. So that's FB. These are going to be inductors. That's going to be ferrite bead, but it's basically an inductor. It provides just a little bit of shock protection. Think of it like a shock absorber for power coming in. When you initially plug in the power cable on this, there will be a sudden rush of current as all of the circuits on the, all the capacitors and the circuits in the computer energize. And so you have these guys here just to cushion that sudden rush of current and just slow it down enough that it doesn't shock everything. So we go through some input inductors, and then we're hitting this MOSFET here. And it's also going to a couple of other places. We've got some resistors going to this area, and there's another bit going up here. But the input is going to be monitored by a couple of areas, so that's not surprising. This is our first input MOSFET though. Let's find out what the state of that is. I'll put my multimeter into diode mode, so we've got the diode symbol up the top there. And I'm going to put my black probe on the left here and my red probe on the right. So we're seeing 0.5 volt of drop through that MOSFET. That's the internal body diode. So that's behaving as expected. So that's power going through the MOSFET. Let's try it in the other direction. And the other direction, we should find that it's blocking. Yep, so we've got over limit there, or open line, whatever you want to call it. There's nothing going in the other direction. This guy's behaving normally. We'll check the gate for good measure, which is going to be this pin down here. And we've got nothing. 0.06. Not sure about that. I don't think that's correct. I need to double check that, but something about that feels off. I'm not sure what reading that should be off the top of my head, but I wasn't expecting that to be low. I was expecting 0.5 volt or over limit again. And let's just check the other direction to that gate. Same thing. I don't like that. I think there's something up with the gate on this MOSFET. We'll come back to that one in a moment. So let's go on to this one. That is shorted. And the other direction. And shorted. So in a surprise to no one, the MOSFET that looks like it's exploded has exploded. So, all right, let's keep following. So we have a suspicious gate on the first MOSFET. The next MOSFET has exploded. So immediately we have to ask the questions, why? And the reason why we have to ask the question of why is we have to remember that right now we're on the main 20 volt or 19.5 volt input rail. These don't have a path to ground. So these have not shorted to ground because they're not connected to ground. These are in line. These are series in the power rail, as opposed to capacitors, which usually connect a power rail down to ground. So if a series device like an inductor or a MOSFET has gone blammo, you have to ask the question of why. Has it just failed spontaneously, or did it get overloaded and then fail? So let's keep following. So we're going to go over to here now. So we're going into another set of MOSFETs. And we're also going through the board. I'm just going to see what's on the other side of those vias. It's coming through to there, and it goes under the cooling system. And at a brief glance, I'm just seeing capacitors on that side. So I don't think that's anything. So yeah, I think we go through a second set of input MOSFETs. I'm not sure why. However, let's keep following the money. So these guys now, let's move on to here. Open line. Check the other direction. Half volt drop, that's correct. Open line. And half volt drop. Yeah, okay, that one's fine as well. So now next question is, do we have a main rail short? Because if we have a main rail short, then the main rail would have been attempting to draw infinite current, which could have overloaded this MOSFET. So once we go through here, we come out onto this plane here. Going into resistance mode, I'll put my black probe on ground, and we'll check this rail here, and yeah, we have a main rail short. So that's the reason why this has exploded, is we have a main rail short that has overloaded the input. Okay, pause for a second, because I just made a massive mistake in my reading of this board. Now, I'm going to discover that mistake in a moment, and then I'll backtrack and go over it again. So in those couple of moments, see if you can figure out where I've gone wrong, but be careful of what I'm saying here, because I'm very confidently wrong. So we have multiple problems here. This is sometimes known as a cascade, where an initial failure of a component has caused other components in the chain to fail. Although, generally speaking, when people use the term a cascade failure, that's usually when a secondary power supply has failed and caused multiple other secondaries to explode along the way. But that's a relative term. However, in this instance, we've got a main rail short that has caused the input to explode. So we need to find that main rail short, and then we also need to fix that input. Now, I would like to inspect this side of the board, so I think I'm going to take the cooler off so I can see this side as well, because we might find exploded capacitors under there or something like that. So I'm going to take the cooler off of this thing, and I'm going to hope that it doesn't have liquid metal, because some of the Minis Forum PCs use LM. I don't think this is one of them, but we're going to keep an open mind about that. Let's zap these screws out and see what's on the other side of the board. No, it's liquid metal. All right. That's fine, we can reapply that. So you can see the extremely meager amounts of liquid metal that's been applied to this. It's a bit of a gimmick using LM, in my opinion. If you want to cool the device, just use a bigger cooler. Liquid metal is kind of just asking for trouble. Alright, however, more to the point, I'm going to quickly stare at the board and see if I can see any faults. Right, I want to double check some things because I've made a mistake already that I've spotted. Earlier on, when I pointed out these vias coming through the board, and I said, oh, it looks like that's just going to input capacitors. That's actually our V-core input. So I need to double check that my measurements here. So I was measuring over here and found ground, but if we actually look a little bit closer here, you can deduce that I've misread the board. So this is a useful learning experience to point out. It's also good because I questioned that I wasn't sure why there was another 2 pair of MOSFETs here, and I should have trusted my instincts on that because that would have revealed the problem. So number one, I measured this bit and found that it was ground, which is where I made the measurement here, and as you can see, I said ground. I was like, oh, it's the main rail short. Well, that's because this is a ground plane. So I measured around here and was like, okay, well then the power is coming through here, and assumed this was a power plane, but actually if we look a little bit closer, that can't be correct, because on our inputs here, we're coming down, we're going into this MOSFET, but we're also going through some resistors and onto this capacitor. So if we're coming through these resistors and onto this capacitor, that means that this has to be power, so this side of the capacitor has to be ground, therefore this must be a ground plane. And this is further supported if we look up, because that TVS diode that I also pointed out, that will be bridging the input to ground, therefore this is a ground plane. So we're expecting this to be ground. So when I measured that earlier on and said it's shorted, no, it's just a ground plane. Okay, so if that's a ground plane, that means that this is another regulator. This is a buck regulator with a high side and a low side. The high side is connecting the main input to the middle. The low side connects the middle to the ground, and this bit is our output. So if we measure this at the center, we can see that it is actually not shorted. So this area is absolutely fine. So this is some kind of secondary rail. It just happens to be right on top of the power input. Okay, that's fine. So let's keep measuring then. So do we have a short or not? Well, I did point out these vias here. So we're coming So we're coming through the input MOSFETs, and then this is our main power rail. And if we check that, so we'll go screw hole to the MOSFET, and as you can see, it's not shorted. So our main power rail looks fine there. And also, by my own advice from previous videos, we're going to measure at GPU vCore. So let's flip the board. So there's the other side of those vias, and we've got some capacitors here and some capacitors up in this direction. And that's why I said, oh, okay, it's just capacitance, it's just going to ground. But if we follow this power trace, it goes all the way around, and it ends up at these power stages. And these are our CPU power stages. So we've got our power stages, we've got our inductors, we've got capacitors, and then we go into the CPU. So this is vCore, and so we're going through those vias into this power plane, and then this power plane is feeding into each of the power stages. So are we shorted to ground here? This is going to be the main power rail because it's powering the CPU, and the answer is no, we're not shorted. So no, there is not a main rail short. That's because I was measuring in the wrong place. Okay, cool. So we've checked, so we've made some measurements. We measured wrong, so we checked our measurements, and now we've corrected ourselves. So we don't have a main rail short, we just have a dead input MOSFET. Okay. So that brings us back to this guy then. And so by all apparencies, it looks like we just have a dead input MOSFET. And that might have failed just because it's probably just a cheap MOSFET that has failed. It happens sometimes. So let's take this guy off the board, and I'll see if I can find a suitable replacement from my donors, and we'll put that on. Now, technically, we should find a pair of exact matches, so we'll have a look into that. But these input MOSFETs, they're generally just general purpose power MOSFETs. Because these are just working as input MOSFETs, they're not actually doing any significant switching. We don't need to be super fussed about finding precise matches here. We don't really need to be worried about timing and things like that. So a general purpose DC in MOSFET from some other device that has approximately the same kind of power requirements will also work just fine. But let's get this guy off the board, and then I'll see what I can track down. There we go. Right, so I've removed the MOSFET and I just added some leaded solder and then wicked it all up again. And the purpose of that was just to make sure that I had picked up any stray solder balls that were rolling around there. Because obviously where there had been some solder that had oozed out, we wanted to make sure that that's not going to cause any problems or go somewhere unexpected. So now we've got to find a replacement. Right, let's check our diode measurements again to see that we've got something that looks correct. So I've got 0.5 volt drop there, turn around, and open line. Should probably be doing this without a metal plate underneath it. And now, this guy is open line, and then swap the probes. And this guy is also 0.5 volt. Nice. Cool. So, those are now behaving in the manner expected. So, I'm going to give that a little bit more of a brush, just to remove a bit more flux residue, and then I'm going to put this back in and we'll try and turn it on. Right, that's everything in the box. Let's fire it up and see if it works. On second thoughts, I'll take my testing SSD back out again, so if those MOSFETs catch fire, we'll see it happen. Boop. Alright, it's immediately turned on. The fan went mad for a moment, and now it's calmed down. Let's get a HDMI cable plugged in. Oh, I didn't plug the hacking battery back in. Alright. That's supposed to go underneath the motherboard, but hey, it fits there and now it's more accessible. Okay, I'll turn it on now with the HDMI cable already connected, so we should actually get a picture. Aha, we have a post. Alright, that looks good. So I'm going to turn it off and put in a Windows SSD now. And what I want to do, I just want to hit it with a slight load, just to make sure it doesn't immediately explode the moment I actually put any kind of pressure on it. So we'll just spin up Cinebench or something like that. Cinebench is not a torture test, however, it's a pretty good confidence test. If it's fine with Cinebench, then that's good enough for me to say, okay, cool, I'm going to close this thing up. Good stuff. That thing's doing fine. All right, there we go. Let's put the cover back on. There we go. That is one fixed mini PC. So I hope you guys found that interesting. That was a slightly closer look at the DC-in MOSFETs. I want to do a bit more detail on what the deal with all of those is at some point. But when it comes to MOSFETs, I'm still learning my stuff about them as well. I'm not super keyed up on what numbers are important in the specification of them. So yeah, but as I figure that stuff out myself as well, I will be sure to share the information. Thank you very much for tuning in. I'll see you next time. Bye for now.